Welcome back to the stream, everyone. This is, well, so first of all, my cat is not in his usual position, but he's upstairs in the loft here enjoying a sunspot. So at least for the moment, I've got the wireless analog camera position so we can enjoy him a little bit. Let's get some recording started, and then I will introduce what we're doing. Just briefly, this is going to be on the SD card emulation project where we're trying to kind of unbrick this PLC bootloader. Audio recording going. Hopefully Tuco doesn't take that click as a... Oh, is he looking for... Now I'm kind of confused about what he's even doing. Maybe he just killed a bug. Anyway, happy Tuesday, happy Pi Day, everyone, if that's a thing you celebrate. So the overall structure of this, this is kind of a continuation of a longer project that I've been doing to develop a technique for extracting the firmware from devices like this programmable logic controller that communicate mostly over Ethernet and have a little embedded web server in their microcontroller firmware. It's a little underprepared for this stream. I didn't have the window up on the screen already. Alright, good morning everyone. Afternoon, wherever it is, wherever you are. It feels a little earlier than it actually is today. So yeah, we've got this programmable logic controller based on an ARM processor with an onboard Ethernet core. It mostly communicates over Ethernet, so I had an experiment to try to glitch it while asking it for a file over its built-in web server in order to try to get out the firmware. I was close to having that working, and then I got a little overambitious with my test setup and ended up somehow getting the device bricked in a state where I still don't totally understand why it's bricked, but seems to be due to something going wrong either electrically with an onboard peripheral or something may have written to onboard flash storage. Either way, I've got this thing into a pretty weird mode, which I could ignore and move on to a backup unit and get on with my original experiment, which, you know, I might be doing that pretty soon, but card full. It's interesting, that camera is supposed to be recording on a loop. Guess I don't that's one of those Mobius cameras that people use a lot of the time for drones and FPV kind of thing. But yeah, it's a good little camera. Anyway, so I've got this experiment where, you know, it's kind of a diversion from my original task of trying to get the firmware out of this thing, but it's potentially a way to save from bricking another device and the bootloader itself or whatever we're stuck in. Basically, we've got this thing stuck in a mode where the only external communications I can find are through the SD card, and it appears to be enumerating all the files in the root directory on the card. So, went through all the trouble to build this test setup, which gives me a way to go in there and, while it's reading the SD card, change what it sees, and then look and see what effect that has on either the timing of the reads subsequent after that, or the power waveform, so I can actually look at what the CPU is doing while it's processing in between reads and see if I can, see if I can have a noticeable effect on that. So at first I was a little discouraged because I went through all the file name combinations and actually I think I've got a video of that. Maybe I'll switch away from the cat cam since it's not quite framed super well right now. Let's temporarily go to the Mac. I just lose the remote control for this one. Alright, so video archive up. And wanted this guy. Load. There we go. It takes some time to enumerate that directory listing. Oh geez. And I don't know how in the Mac UI to close all of these open folders. There's got to be a keyboard shortcut for it, but I don't see it somewhere that's discoverable. Yeah, I don't know. Anyway, I was going to try to find the time lapse that I recorded most recently. Is that this one? No, that's too recent, actually. The older one. Okay, yeah. So this was an earlier experiment. Let me make this a little more visible here. Oops. There we go. Let's actually open this in a real application. So this is kind of an earlier iteration of this experiment than what I've currently got on my desk, but let me pause it momentarily. So this window here is connected to the serial console on my system on chip that has a CPU and an SD card emulator. And then this is the oscilloscope. We're seeing digital traces that mostly just tell us where the actual SD card transfers are. So this is the end of a block read where it was getting file directory, it was getting sectors from the FAT file system's root directory table. And then here's the next read. So in between these two reads, I determined elsewhere that this must be where it's actually processing the reads, which makes sense. That's the most straightforward thing to do, but it's possible that it's reading the whole thing into RAM and then processing it later, but I did some other tests that ruled that out based on changing the number of files in the sector. And so you can see by turning the number of files down, then this gets shorter dramatically as it reaches the end of directory, sort of null terminator there. So this is definitely the processing we're interested in, and this down here is a zoomed in representation. The blue trace here is kind of a very amplified representation of the voltage rail on the CPU. So this is the 1.8, I want to say. I think it's actually less than 1.8 volts. Anyway, I'm forgetting the actual voltage, but it's the low voltage CPU core voltage that I'm then putting through an AC coupled high gain low noise amplifier, and then that's what we're seeing here on the scope. So what I would expect to see is as I iterate through different file names, if my theory that this is just a for loop containing a bunch of string compares or memory compares, if that's correct, then you would see as soon as you hit upon a file name that starts to be a little bit more correct, so like maybe the first letter matches and then it's making it to one more loop in the compare, then you would either see this waveform would shift over a little bit. Some of this is actual CPU power consumption and some of it is like resonance elsewhere. So some of this might shift, some of it might just like amplitude might go down here whereas it goes up here. So there might be different effects to look for here. You might see the timing over here change, so this whole operation ends up taking longer and then it doesn't start the next packet until later. So those are the kinds of things that I was looking out for. And in order to just so I started doing that a little bit manually, but didn't really see much. And to get a clearer idea of what was going on, I set up this automatic test where the firmware on here just every 30 seconds increments the letter here, and then we can see over an average of many samples whether there's any noticeable change. And so this would be a sensitive enough test to detect even small differences, but I didn't see anything even after going through not just the letters, but just every byte value here. So I was kind of discouraged by that, since it seemed like the thing that it would be looking for there was the file name probably. But I noticed a couple of problems with this test. One of them, the timing wasn't quite as consistent as I needed it to be. Once I started looking closer at this and turned on persistence on the scope and just tried to track down all the little timing anomalies, I started noticing that sometimes it was off by 1 clock cycle, which just shouldn't ever happen. And then actually trace that down to just some other feature. Actually, it was the terrible clock speed divider thing in my test setup that I think was responsible for the bricking. I hadn't completely disabled that, and something it was doing was responsible for like glitching a clock cycle. So that was bad. I turned that off, and now it seems to be stable. And so anyway, I also wanted to. So I thought about it, and I thought about, well, what are some reasons why this wouldn't have caused any change? Is it that something is hiding that change? Is it written in such a way that differing data doesn't cause it to take a different amount of time to execute? Or is it getting resynchronized somehow by waiting for an external hardware clock, like on the SPI engine? And none of that really turned out to make any sense. So it did seem like it was iterating through all the file name entries, and each time deciding that the file wasn't something that it was interested in, but doing so based on something that wasn't the file name. So based on that, I really wanted a tool that let me experiment with the contents of the whole FAT directory entry, not just the file name itself. So that's when I started making some improvements to the test setup here. So let's go back to the other computer. Oh, not that one. Oh man, this thing generates the weirdest glitches when it doesn't have any inputs. Okay, so I made a few changes in this whole contraption. Let's go back to the laptop. Oh, let's see if the cat cam is showing anything good. No? Oh well. Okay, so, I made a few changes to this whole contraption. The biggest thing really is I added this little kind of interactive hex editor layer. So if you're writing an experiment for this code, you can now kind of create this hex editor object and attach it to a buffer and then interactively edit its contents. Let's see. So now the experiment actually looks a good bit nicer. So this is the C code minus all the kind of common library stuff. This is just the stuff that's specific to this one experiment we're doing. Okay. So yeah, it's got a main loop here that just sets up the hardware and its libraries. We've got this buffer called guess that is the size of a FAT directory entry, so 32 bytes. And we initialize it using the library's kind of normal FAT directory entry code to just be a regular file with kind of an arbitrary location and size. You can see there's the guess buffer up there. What is that? Somebody... What? That is really weird. Okay, so this is apropos of nothing, but there's an Android phone over there that I guess was on that I occasionally use for just like random GSM experiments, and somebody was calling it. No one should have the number for that phone, so it must have been just random. So, oh yeah, and also as a aside, the weather here is great. I hear it's pretty stormy in the east. It's kind of warm here. Interesting how different things are just thousands of miles apart is all. Yeah, let's see. So then we have this main loop where the main loop is kind of keeping track of two different things. It wants to periodically draw out some status to the screen, including, all the status that the SD card emulator keeps track of, kind of our own custom status. So like, is that auto increment feature on, and how is its countdown looking? How many files are we serving? But then it's also printing out this hex editor window, and then periodically updating that, but also updating it immediately if you have some keyboard input, so we maintain responsiveness. And that's pretty much all this has to do. Our root directory has to either be the fat volume label, which is just a special case here, which I don't think we need to mess with, or just a bunch of copies of this guest buffer. And that's so that if we make a change that causes a different execution path, it'll amplify that by 32 copies of this directory entry for one block, or 16 copies, I think, or much more than that over the course of the entire root directory. And then we're also doing the triggering a little differently here, so that we've got a separate trigger if this block is the very last one. And this actually just writes directly to a hardware register that we're then latching into some general purpose outputs. Or not general purpose, but it basically looks like a GPIO register, except there's no input, and the output has this special purpose latch on it that's triggered by the end of a data transfer. So I think that's all. So I was actually going to modify this slightly because I wanted another little change for usability's sake. But I can show you what I have so far. Connect to the bootloader, just to make sure we have the latest code. So this is running on the system on chip now, and I can move around here. You can see the little brackets indicating what part of the record I'm editing right now, and I can increment and decrement particular characters. I can actually just type hex values if that's what I want. I can make the cursor wider and then update several things at once, and just set them all to the same value. So, and that seemed to be basically the primitives I wanted. There's also still that auto increment thing. So if I press capital A, I think, yeah, then it basically starts a 30-second countdown, and every 30 seconds does the equivalent of incrementing. So then I can set that and leave the video on a time lapse and come back later. But I just wanted to add a quick feature to this first before I get too deep into it. I wanted something that actually just prints out the hex address of the cursor, because that would be super useful. So I don't know if I want that to be part of the hex dump utility itself, since I don't know if that's always going to be something I want taking up space on the stream, or on the space on the output here. This is largely limited by how slow the serial port is right now, I think. But yeah, I think I just maybe want it here. So let's just put it something like cursor equals, and then this will be an address. And then maybe I'll just have another X here to indicate how many bytes, and then the number of bytes in hex, but without. That looks really confusing as a printf format string. But this is a %04xx%x. Doesn't that make sense? I think that's what I want. Let's see how that looks. So then, because this is just a structure, I'm just going to reach in and grab the values I want. So editor.cursor adder. I think I just called this cursor num. Or cursor size. Oh, cursor low and cursor size. I guess originally I was thinking of it in terms of a high and low address, but then size made more sense. So I'm thinking of it as a low address and a size. Anyway, experiment, cursor low, cursor size. So then it's nice and fast to reload the firmware on the system on chip. Oh, yes, I did mean cursor low, actually. Actually, I meant to delete that because there's too many things. Bootloader. Also, I keep being tempted to, I'm using C mostly because that's what the MySock examples were all written in, and it seemed easy enough, but I've been tempted to switch to either Rust or C++, depending on how adventurous I'm feeling. since, I mean, even little things like, you know, I'm not going to use like STL containers necessarily, but like having to use the old style like C min and max macros, like, I hate these things. There's no standard header you can get them from. So if you want them, you either have to put them in your own header or include them in your source file or whatever. They, you know, because they're macros, they're evaluating the arguments multiple times. And, you know, and not evaluating them conditionally based on the condition. I mean, yeah, I mean, it depends on what you want. Usually what you want is for this to act like an inline function. And so I actually really like the C++ algorithm header. And it doesn't have any runtime overhead. It's just a nice language construct, but it does require that you actually compile the file in C++ mode, which has a couple of other trade-offs. Anyway, I think that's all I wanted. So now I've got that. Yay. Okay, so I've got persistence mode on. I've also got averaging. I think I had the averaging set. Well, okay, sorry, this is unnerving me because this is now wobbling back and forth in this way that I'm not expecting, which we might have to debug. I thought I had this pretty stable after fixing my clock, but maybe the two issues were unrelated and fixing the clock just temporarily masked this problem. Okay, and now the problem's gone again. So it also might just be something I'm not seeing on the scope. Anyway, the thing that I was concerned about was, let me see if I can point it out with the mouse. So down here in the digital outputs, these outputs D0 through 7 are the trigger outputs from our, you know, that general purpose latch that I was just talking about. And so with that, basically the software is saying, here's the value I want you to pulse out next time a transaction completes. And then right on the clock cycle that we finish writing the last, like basically right after the CRC goes out on the data packet, we latch that, you know, using an SD clock edge. So it should be really stable relative to everything else that's going on. But then I was seeing these moving around relative to D8 here, which is a debug output showing us, I think this is showing us the, oh, now I'm forgetting whether that's like the transaction active signal or something else. Maybe I should check that before I make too many assumptions based on it. So that debug signal comes from over here. It's the board specific Python. So this Python file is basically defining how the hardware on this board is designed. This is like the top level module that actually generates the wiring for the FPGA on this board. And so it has a little bit of debug here where it's taking, so up here this is like some platform specific I/O that we're adding and giving a name to. So this corresponds to D0 through D7 on the scope. Those are the trigger pins. And these two debug signals are D8 and 9 on the scope. And so that's just connected to data out done, which I was debugging because that's what we're using to trigger the those latch pulses. This is like the input to the trigger module. And then command in active is just something I was using earlier for debugging the state machine on the SD card. And you can see that it was active as of a long time ago because we were in the command, but then it finishes kind of over here as the state machine is resetting. But that doesn't have a timing that's super useful here because that's kind of a little bit arbitrarily later. What we really want is something based on this timing. But the problem I was seeing before, which I thought I managed to fix, but maybe I'm wrong about that, the problem I was seeing was that it seemed like this edge on D8 was moving around a lot relative to these edges on D0, 1 and 3. But what was actually happening was those were just moving around by one clock cycle, and it seemed like the difference was a lot because it was crossing two of those byte boundaries. And the way this SPI controller works, it kind of clocks out one byte rapidly and then stops the clock between bytes. So we were seeing that difference in clock cycle durations, basically. And that shouldn't happen. Like, we should always be finishing this like right on the last clock cycle of the last byte of the CRC, and then we'll get that pulse on the first clock cycle of that next byte, which in this case is kind of a padding byte. So this isn't necessarily the optimal timing. You know, it might be better to latch our output right here on this edge instead of waiting for the next positive edge. I guess part of why this is weird is that this logic is being clocked out on the negative edge of the SD clock, because that's where we're preparing the next data for the other end's positive edge to read it. Whereas over here, this is using kind of the default convention of positive edge. So this, it's really weird, but basically this whole length here, which is like 6-7 microseconds, this is just between the negative edge and the positive edge of the SD clock, which is annoying, but not a problem. Anyway, what was a problem was I was seeing that jump around, which I'm not seeing now. So maybe there's a way I can provoke it to do that again. Maybe if I hold this and reset and give it somewhat different reset timing. Because right now it's on a 1 second periodic reset from the scope's wave generator. Huh. Well, okay. I think what this is telling me is that my problem that I thought I fixed isn't necessarily gone, but it's gone right now, and so maybe I can ignore it until it shows up again and then try to fix it. So this is now back to working as I expect it. So here we're seeing, this is the last byte in the CRC of this data packet, and you can see on the scope persistence that there are a couple of different kinds of packets we're getting. This should change even more if I'm interactively changing the contents of the directory entry. So if I'm going through here and, so I don't think this is going to change, well, from what we've established so far, if I change the file name, the firmware isn't going to care yet. There's still something else preventing it from caring. But we should at least see the CRC change. Oh yeah, that's changing quite a lot. Great. That's what we would expect from any kind of change to this block. But the timing stays the same, and we're still seeing something really consistent on the power waveform, so that's nice. So now, okay, I'm going to get the scope set up to view this at a slightly better zoom level, but then I want to show you the uplifting quirk that I discovered recently with this. Okay, so I think this is the area we're really interested in. So here we have a read from something with directory entries in it according to these triggers that were set up by our software and then timed by our hardware. Then this is the region of time where the microcontroller is actually processing the directory entries. And it actually seems pretty stable now. Actually, I'm curious what it looks like without averaging. Even without averaging, you can kind of see what's going on. Or at least I can on the scope. I don't know how clear it is at home. But let's try, can we go down to 16 averages maybe? Nice. Okay, I'm happy with that. So now we're actually getting a pretty clear view of what's going on, at least in terms of the looping parts and the parts before and after the loop. So this trigger I'm going to place right here at this little gap, and then we can actually see a bunch of those. So we've got 1, 2, 4, 8, 12, and then this would be 16. So it looks like that little, what looks like kind of a gap in the power waveform, or basically a brief period of low power consumption variability, that seems to be happening right before each of the directory entries it's processing, and then kind of a bunch of more active stuff. So, you know, one of those might be waiting on the hardware or doing like a mem copy or something. It's kind of hard to tell what's what at this point, but those definitely look like individual directory entries it's processing. And we can tell, again, that it doesn't seem to be responding to changes in the file name portion. But let's see. I remember my keyboard shortcuts. So this over here, B, that's right after the file name portion. This is like flags, like, is this a hidden system file, a directory file? And I started going through these, and I think we'll see something interesting at the boundary between 3F and 4O here. Actually, I think that changed too from 3F, between 3F and 0, because now they're all much shorter. It's ignoring these. If I go to 4.0, oh, now it's just back to the normal. Okay, so maybe I saw something where it was actually skipping files due to some of the earlier bits. Because this was going to be weird, because 4.0 is actually a bit that's reserved on disk. It's not supposed to mean anything. So it makes much more sense that we would be seeing something due to the absence of some of the lower order bits. And that's nice. So this power trace is much cleaner than what I was seeing before. It's making it much easier to see what's going on. That's great. Okay, so are we actually seeing this? Can we isolate down individual bits? So 4.0 is fine. What about 2.0? 2.0 is fine. Where by fine, I mean it's spending more time rather than less time evaluating each one. That also seems like maybe it's doing something like... So if we go back to 4.0, oh, is this not going into its short mode anymore? Okay, yeah, that's right. I'm getting logic backwards again. So 3F is how we got it into the short mode. So yeah, it's still visiting all the entries, but it's skipping them somehow. But it is, so I guess what this makes me wonder if the code that we're seeing it run normally, that it's skipping now, but it wasn't skipping before, if that code, which doesn't seem to change length depending on the file name, if that code is still related to the file name, and maybe it's copying the file name or doing a comparison that doesn't change length depending on whether it's right or wrong, so it doesn't have like an early out. Anyway, that's interesting. Let's keep going and try to narrow this down. So let's make this 0. That's back to the long state. I don't think the persistence is helping right now. Okay, so 1, oops, 0, 1, 2, 4, 8. Oh, 8 is important. What is the 8? Let's ask Wikipedia what 8 means. Oh geez, my VM is full screen. I don't actually need this to be full screen right now. So this structure we're editing is basically, if you go to the Wikipedia definition of the FAT file system, we are talking about directory entry. I lost the heading for that. Oh, I guess it's in the URL. Can I reload that? How did I lose my place in this giant document? There we go. I don't know why I wasn't finding that before. Anyway, directory entries. Yeah, so as you can see here, this was originally like a legacy thing, and this doesn't really serve as the main source of file name in modern disks, but for something like an embedded system, I would still be surprised if they weren't scanning this. but that is something we now have a tool to find out. So offset, we are right after the file name at offset B. So we're at flags, and 8 looks like what we want. Oh, 8 is a volume label. Okay, so it's just skipping it if it's a volume label. That's fine. That's not interesting. It's totally predictable. What else are we seeing? So it is visiting it if it's a subdirectory, which is weird. I wouldn't expect it to care about the other flags. Okay, so maybe what we were seeing before was just an effect of having that volume label bit set. That is now much easier to see once we have now that we have a better tool for this. So leaving that 0 definitely seems to be a step in the right direction. So what is next after that status, or that flags bit? So we're at C. Now we have some stuff that seems pretty legacy. I'd be really surprised if anything cares about this byte. We can run through it just a little bit, but I would be surprised if anybody cares. I don't see anything changing. Okay, let's make that 0 and move on. So D, this is backup storage for the first character of a deleted file. Oh, or with VFAT, it's an additional byte for the file creation time. I also wouldn't expect anybody to care about that. I mean, briefly scrolling through the values isn't going to tell me if they're looking for something really specific, but I don't think it's worth fussing with that quite yet. This is more timestamp stuff. Password hash? Weird. I'd be surprised if they were checking the timestamp, but I mean, I'm already somewhat surprised since the file system or the file name changes don't seem to be doing much. I mean, we could try making this like a long file name. I don't remember how that works, but we can look that up. Maybe more likely is the file size. Like if they don't want to have to waste time doing the comparison and, or doing the name comparison before looking at the size, they might be looking at the size first. That'd be a little strange, but maybe let's look at that next. That's at 1C. I think that's the last 4 bytes. So with this, I guess if there was a difference to be found here, I would be starting with maybe the most significant byte and then looking for some really small change between, say, 0 and 1. Because I suspect the thing it's looking for doesn't have anything non-zero in its most significant byte. I was going to use the timing between the end of the last transaction and the chip select low here as a kind of guide. And the persistence might actually help now. No cursors. Okay. So here we're looking at basically 135 microseconds past where we're triggered and trying to see if there are any little differences in how long things are taking. Not so much. What if I set the size to 0? Does it even care? don't think it cares about the size yet. Because I also would really not expect it to care about the file's location. Does it care about anything in the second half of this? It seems unlikely. So, I mean, it's showing all the signs of it actually being looking at the file name, except for us having seen some success at that. So maybe it's worth just going back and trying that again now that this tool is a little more, successful. Just reset this to get back to a clean guess. And just can we zoom out for some better context too? I mean, really don't think I want to include the entirety of the SD transaction in this if I don't need to. We'd just be looking at the computation time. Oh, I might want to bring back a change that I made earlier where I separated out the triggers, so instead of having one trigger that's always triggering on root directory entries and another one that triggers on the last entry to make it so the last one and all but the last one are mutually exclusive. Oh, I just noticed out of the corner of my eye a call for can I call the cat? And actually, he's over here. You probably saw him and I didn't. I think he likes looking at the birds out there. Okay, getting this scope on. Actually, yeah, the trigger. So that's another small change in the system on chip. And in fact, I think I had this change before, but then I reverted it because I didn't think I would end up wanting it long term. So where's the other trigger? So the other trigger is in here, I think. I just cannot learn the difference between control and command anymore thanks to Linux VMs and Mac OS. I need to just... I mean, I guess part of the issue here is that VMware Fusion has a bunch of key remappings that kind of paper over that difference for a few of the common ones, but then if you step outside that, it all breaks. So it's probably a bad habit. Trigger. Yeah, so this, I think this is what I want. I just want to move this into one of those. So now it's giving me separate triggers for the end of the fat root directory or just any other block. Experiment. Yay, okay, now the scope is a lot more stable looking because I'm not getting that last block, which doesn't have a block following it, so it looks different. Okay, I don't really want to zoom in any more than this because I like having that overview, but can we get a close look at this end here? And less clutter, maybe. Okay, it really seems like I should be able to see some of this power waveform moving around if if I start to change the amount of progress it makes. This also is a little easier to see without persistence on. All right. So does this care at all about zeros? Yes. Because now that's like not a directory entry anymore. Now it is a directory entry. Can I set everything except the first byte to zeros? I mean, I find it hard to imagine that they would be doing something other than a string compare or a mem compare here. Like, it seems unlikely they would have gone out of their way to try to harden this particular comparison against timing side channels. So far, the power trace is very steady. And the way, so we're seeing right now an average of approximately half of the packet reads that we're seeing as the firmware reads the entire root directory. Oh yeah, US Water Rockets asks, is it possible the firmware is looking for a specific directory, or has that been ruled out? That has not been ruled out yet. That would be a good thing to look for too. Try some of this with a directory flag. I guess though that one thing that I would have expected if that was the case was that setting the directory flag itself would change the amount of time it takes to do the comparison, because then it would be getting further and... Because what we're seeing now is something that seems like it's taking a lot of time relative to not even looking at the file. So for example, I mean, so 0, it just completely stops reading the table entirely, which makes it hard to tell what's going on. But if there's anything non-zero there, then it does read the table. And then if we go over to B, which is right after the name of the file, then if we set that to something, like if we've established if we set the volume label flag, then now you can see it's taking a lot less time, maybe not a lot, but certainly a noticeably less amount of time to actually evaluate that file. And so, well, which one's the directory flag again? So a subdirectory is 10. I think we already tried that, but let's just make sure. So this is just for control, offset B, 8, we're seeing this again. 0 is longer, and then 10 seems the same. And that's weird because that tells me that it doesn't care whether or not this is a directory, which is a weird, kind of a weird stance about directories. Yeah, Mike in chat mentions if I were writing a firmware updater, I'd be looking at the file size. I agree, I'd be looking at the file size too. So far, this doesn't seem to be, but I mean, I think the scope setup we've got right now is pretty sensitive. Like, I would expect this to see... Oh, Tuco is sitting right next to the camera. Let's see if I can adjust that. Faster. How are you, little cat? I think he likes it over there next to the sun. Oh, file size. So, like, I was looking at this. Right now, this is just arbitrarily, like, I think four blocks. So, like, if it was looking at the file size at all, I would expect it to care about differences between, like, 0 and non-zero, or I would expect it to care if... I mean, I guess I'm assuming that it's checking 1 byte at a time, whereas it has no reason to check 1 byte at a time if this is a 32-bit OS, or a 32-bit processor. And so if that's the case, like if it is looking at the size next, then, and it's comparing it all in one go, then I might have to do something more exhaustive. I mean, granted, if I just start from 0 and count up, or even just try some common powers of 2, then that's going to take a lot less long than enumerating all 32-bit values, I'm sure. Because yeah, it does, I mean, just looking at, first of all, the amount of time it takes different between I mean, it's still mind-blowing a little bit that it doesn't care about whether this is a file or a directory yet. But, man, yeah, so this difference here, can I get the scope on just that first one so I can see the difference in the single iteration? Oh my god, I'm always getting that cursor warning by accident. I know, go away. So that's the two different states I've got. Man, that is a nice clear difference though. It shows you like right where the execution paths diverge. I don't know if it's quite as clear on the stream because the colors are maybe a little weird on the scope through the capture card. But you can see on the bottom trace there that there's a portion of it that stays totally phase locked, and then there's a portion that just kind of gets skewed in phase, and then the averaging has to, kind of catch back up. So we're looking for more of those changes, but here we found one where the non-default state actually gets us more progress than the default state gives us more progress than the kind of change we found. But yeah, maybe something like that for file size would be handy. I mean, yeah, there isn't really much I can do here without running a long time-lapse test, unfortunately, because if it's not checking each byte separately, then I have to check these somewhat exhaustively. So I might do that, but I might try to do something more interesting first. Let me catch up on chat quickly. Oh. Yeah, we're talking about in chat like what the kind of how complicated this might have been, and are they likely using encryption or yeah, I mean, it's a good question. Like, I would not be surprised at all if they're using some form of encryption. I would be surprised if it was good, and if there wasn't some other way around it, because that's usually where these things fail in embedded systems. Is people are like, I'm gonna use AES encryption on my firmware, but then there's some workaround that makes it trivially easy to extract the key, and that's a lot of times what happens. But yeah, I mean, I don't, I'm certainly not expecting that this is definitely going to be successful, but it seemed to work, definitely worth trying at least. Let's see, what is next though? So, okay, size, can't necessarily do much with size. Where would this be storing long file names in case it cares about that? VFAT. Oh, here we go. So an attribute combination. Oh, okay, I think we might have already accidentally tested this then, because that's also in this 0b byte. This is saying that VFAT has an OF attribute in this to signal that it needs to look elsewhere. So I think we would have already seen that, but let's just try it just in case. So just as another control experiment, 08 should give us a smaller response. Okay. 00 gives us our normal one again. And then OF is VFAT. Oh. That's interesting. Is that distinct from other similar bit patterns? No, that might just be the 08 again. Okay. Well, maybe that's just, I mean, I suspect that's part of how VFAT gets its backwards compatibility, is if you don't know about VFAT entries, then it just looks like a really weird looking volume label. And so I think that's what's going on. I think that might confirm that this is not long file name capable then. Oops. My hex editor doesn't have backspace, and it doesn't accept O as a substitute for 0. Yeah. That is going to be the same as the 08. Yep. Okay, so no long file names for us. I wonder if there's going to be any point in just fussing with the extension on its own. Like, is it maybe checking the extension using some hard-coded test? So that would be these bytes right here. Yeah, I think we're gonna... I think we're gonna see anything easy there. I mean, I might have to set this up to run some more kind of slow and boring tests to find the good values at this point. Oh, that's a good provocation from Idella, who just arrived and is wondering what they're looking at. So this is kind of a weird nested experiment where overall I'm trying to extract firmware from a logic controller, a PLC device, and partly because we want to evaluate how secure the firmware is, and partly because it would be an interesting technique to develop. And then in the course of that, I bricked it a little bit, and now I'm trying to unbrick it by prodding at the one interface I can see it actually trying to talk over, which is its SD card interface. So this window here that we're seeing is a terminal connected to, actually I should have this on the camera. I haven't actually been showing the hardware on the stream yet. This terminal is connected to a little FPGA dev board, which is running an SD card emulator that I've hacked together. And the SD emulator is pretending to be a file system that I can kind of flip through different combinations of values in order to see which ones provoke different responses out of this software that I'm trying to figure out, what state it's even in. So the red waveform is me listening really closely to the power consumption on this device. I think I want to format this SD card first, speaking of SD cards. Alright, let's so this thing right here is, actually I have one of these in its pristine configuration now. This is what they normally look like. It's a good visual aid to have for this experiment. So this is currently my backup unit. Once I give up on really getting this unbricked, then I can go back to experimenting on here, but I'm trying to delay that a bit. So the idea is you rack mount this in your corn processing factory, or your, whatever it is people use these for. Your bioreactor making beer. you have something like this controlling a bunch of relay outputs, and this has a handful of inputs and outputs. This has 4 relays on board and 8 digital switch inputs, but then the idea is you can also stack additional I/O expanders on here that communicate through this port, which I've looked at this port a little bit. It seems to be a combination of SPI in one direction and async serial in the other, but so far it does not seem to be a good way in. Then this is Ethernet, which is usually how you're communicating with this thing and downloading programs to it, and it's going to be connected to your network and possibly to the internet at large, which makes these things kind of interesting. So anyway, I had been experimenting with one of these through voltage glitching and that Ethernet interface, and then now that I'm kind of trying to unbrick it. So you can see I'm rebooting this thing once a second to get oscilloscope traces, and every time it reboots, you can see it initializing the LCD, and then it just gets stuck. So it's not really getting very far. The only hardware I've seen it talk to is the LCD and the SD card. And then this cable is plugged into the SD card socket, and then into my adapter, which goes off to, so actually before I move on from this, besides the PLC itself, which you can see has been slightly modified so I can get at its voltages a little more easily, got breakouts on the flash memory and the real-time clock, because I was concerned about it for a while, but now it doesn't seem to be relevant. And of course power. And then that little board that's running off to the oscope, that is the low noise amplifier that's pulling off the tiny changes in power consumption and letting us see them. And this isn't being used right now, but it's the board that I was actually using to deliver the glitches. So it's what would stabilize the voltage regulator normally and then very briefly very destabilize it. Then the SD card over here would plug in kind of to a weird little daughter board, and then I have this ribbon cable plugged in over there. This goes over there. And then this is a FPGA board called the Papilio Pro, which is actually pretty modest little FPGA. It's a Spartan 6. Yeah, can't quite see the name on there right now. But yeah, it's got a little Xilinx FPGA, 8 megs of DRAM, and plenty of IOs for this experiment. And then that's running over to the oscope where we've been analyzing the experiment results. Oh, another good question in chat, if anybody remembers what that LNA board actually is. It's a little hard for me to pick this up right now, but I have a few spares that I can grab. So it's basically just one of these. The input, I added a couple of resistors on the input for impedance matching, but then the output is pretty much as is. I picked these up on eBay. They were just sold basically, I think, according to this frequency spec. They were like 2 gigahertz wideband low noise amplifier. Not actually sure what that chip is. I think it's labeled N02. It's got a built-in bias T for powering the amplifier. I forget what the range is, but I've been running it off of 12 volts and it's been quite happy. I think it starts at like 7 volts, and then as you increase the voltage, the gain increases somewhat. So yeah, these were cheap on eBay, and they seem to work really nice for side channel analysis. You will need a 50 ohm termination on your scope, but if your scope doesn't have one of those built in, you can just add a T and put a 50 ohm terminator on there. And I've been using that without the chip whisperer itself connected, because at this point the chip whisperer, its analog input just isn't quite nice enough to not mess up the quality of the signal I'm dealing with, since it's so low amplitude. So the only things I have connected directly to the vCore rail on this processor are the amplifier and this glitch board, which is normally just stabilizing it with some capacitors. And the two are both connected to the vCore with separate wires. They aren't like daisy chained or anything, which I think is probably important. I haven't actually checked to see how important that is. I lost track of where the cat ran off to. Hey, Chico. Your fans are missing you, honey. You there, Chico? Oh, cat. Cat's gotta have his bolts. Okay, well, I'm running out of ideas on here, which might mean I set up a time-lapse experiment while I think about more ideas, but just trying to see if there's anything else I can do before setting up something boring like that. I mean, at least the timing is seeming pretty stable now that I've fixed my glitchy clock and filtered out the last packet from the directory. I think it might be even slightly more stable if I filtered out the first one, because I think it's also going to be a little different. But it's plenty stable enough. Like, I think the software parts that I'm actually looking at right now are quite stable. Oh, yeah, silly question from Mike, whether I've read the docs for firmware update procedures. I have somewhat. There don't seem to be any. I mean, I've even looked through the software, and I haven't found any code that seems like it is related to sending firmware over the serial port or anything like that. They don't seem to have any firmware for download. I mean, that's like mostly why I got called into this project, was they, you know, my coworkers would usually just download the firmware image and look at it, but this one didn't have firmware updates available. Yeah. All right, well, I might have to wrap up this stream so that it doesn't just become me poking at a hex editor silently while everyone's bored. I was also thinking that, I mean, there's just not much in here. I mean, there's the file name, there's some flags, there's a lot of weird legacy stuff that isn't used, there's timestamps. I mean, I thought that maybe it could be timestamp related, but I mean, so far my attempts to scroll through those haven't really shown any differences either. Well, I think maybe the next thing to do is file name or file size and see if I see any differences there, since it does look like we're seeing something that is, I mean, so we know it's looking through every file. We know it's ignoring volume name files. We know it doesn't care about the difference between file names and directories. It's hard to tell whether that's intentional. Like, is it going to check that flag later? Did they just never bother checking that flag? And if you had a directory named the same as the firmware update it was looking for, it would just try to read the directory entry as if it was a file. You know, it's hard to tell at this point. Yeah, it does seem likely that it might be looking at the file size or the extension in a way that is hard to, that it's like not breaking it up into individual bytes if it's just, I mean, I'm trying to imagine, like, how would they have coded this like that, such that it, I mean, like, I can imagine them, like, copying the file name into a stack buffer and then checking that as, like, a few uint32s. But that would be weird. People wouldn't just do that unless they were doing something for a very specific reason. Whereas checking the file size, like doing that as a uint32, seems pretty natural since it is aligned in the structure. Oh, and Phil in chat says maybe there's a chance that the firmware update is done by the software you use to program those PLCs. That's part of what I already looked for. So I mean, I have that software installed, and I've tried poking around inside of it, reverse engineering it a little bit. I didn't find anything related to serial communications or anything that seemed to be sending a firmware update over the Ethernet. I mean, and of course I can't rule out that being in there, but I did take at least a small look and see if I could see anything obvious. And that software was pretty easy to see inside of. I think it's all Java, and it was pretty easy to decompile. And you basically have symbols for everything. Oh, that's interesting. Another comment from Mikhail in chat, who suggests it could be a stir looking for a character in the file name, and then it would be the same length for any file name that you have without that character. That's certainly possible. That I would have expected that to yield a difference when I went through my exhaustive test of all the characters one by one. So I think I'll need to do some more of that. I'll like work on something else while I leave this running. I guess one thing that I might want to do that test, well, I definitely want to change my my auto advance counter, because 30 seconds is way too long now that I've got this experiment running much faster. I think let's just set that to 2. That seems to be roughly the rate we want. And then I think I just want some behavior where I can increment as a number instead of... Because right now when you auto increment and you have a wide cursor, it just sets them all to the same value. Just concerned about how much to mangle my experiment code for this case versus making it a separate thing. Oh, interesting. Garrett in chat mentions that there are updaters for some models of the logo PLCs online. Let's see. This is the 0BA8, which is I think one of their. There's like a. I think there's like a much older series of these that work somewhat differently. And then they like redesign them all at some point, and that there are a couple of different ones that they currently sell based on this architecture that have different I/O options. There's the it's a pretty recent device. The little SD card drawer that we're hacking into. These buttons feel pretty bad, even with the thing fully assembled. Mr. Antbox in chat is saying something about a file name, logo up.bin. I mean, I have SD cards with that file on it. If I remember right, that's just what it calls the PLC software. It's not especially useful. It's just a dump that's pretty much in the same format as the MRAM chip on here. Or not the MRAM, but the SPI flash that holds the program. I mean, if we go back to the scope, thing takes hex input, but not ASCII input. I mean, the reason I haven't been like exhaustively trying specific file names is just because I really can't imagine something they would be doing, or I would have to get the entire file name right for it to have any timing difference. Like I can imagine that change for stuff like the size, but not for the file name. Alright, well, I think it might be time to regroup and end this stream and run some slow, annoying tests that aren't really worth sharing. Unless you can think of anything else exciting to do before I do the drudge work. Oh, a suggestion from Pakakezu, I think, in chat, name length. That's an interesting suggestion. There isn't like a separate field in here for the name length, so like one thing I can imagine that meaning is like maybe they're scanning backwards instead of forwards. But I still would have seen that cause differences if I'm changing the entire name field one character at a time like I was. So, well, and like I could start adding like spaces over here. But like so far I have not seen it give me any differences in calculation length based on the contents of that name field. Like, it's not even caring if these are null, so it's probably not doing a string compare. And it is going to care if the first one's null, because that means it's the end of the table, but if I set this to anything except null, then as far as I can see, this is always taking the same amount of time. Like, I would have expected any of these small changes to show up as a time difference if it was checking the length or scanning from the end of the string first. Hey Tuco, is that you chomping around upstairs? Well, on the bright side, this test setup is nice and stable now. I've got a good power trace where I can see quite a lot going on. I can definitely see each of those 16 individual tests. Well, Kyle is suggesting, well, if it's doing its compares a word at a time, then that won't show up this way. Yeah, that's possible. Maybe that's what I do for testing. Maybe the thing to do is to give my hex editor thing like an increment width, so I can increment things with at 1 byte granularity and repeat those bytes, or increment words and repeat those words. That would be maybe a generic enough change to make that I could write that one piece of code and then use it to run a handful of different tests. I think that's what I want. Cursor data width or something like that. So I designed this hex editor to be pretty straightforward, and there's this internal validate procedure that just like anytime you mess with its parameters, it just kind of pushes them back into range. And then the UI basically just glues the keyboard inputs onto those parameters. So Need something here that restricts that cursor data width to be in range. So something in between the entire size of our cursor and a single byte. And then let's add some keyboard shortcuts for changing that. Oh, I never use these that change the cursor size by 16, so I'm just going to modify these to change the cursor data width. And then I need some feedback so I can see how wide the cursor is. So the UI is all drawn by this really simple function. Most of this is just kind of a regular hex dump where I have addresses and then hex values and then ASCII values. The cursors are all drawn by this little helper function that calculates what character should go in between 2 bytes in the hex editor, given 2 addresses. So I think when I have a cursor that has like linked data bytes, I would just show that as like having like dashes in between those bytes here. So maybe so the reason this has 2 different parameters, even though usually pre and post adder are just separated by 1, is to handle the edge of the screen. I don't really have... Oh, yeah. This actually should maybe be different, because this has the kind of separator at the beginning of the line is kind of from a -1 kind of non-existent address to the address of the first byte. And then you have this one that just goes in between 2 nominally for every for every pair of bytes, but really this also ends up using this for the byte at the end of the line, which is not necessarily what I wanted. Anyway, I think what I want here is if the pre-adder minus the beginning of the cursor, so the cursor low address, if that whole thing I guess I'm just changing course in the middle of saying that. Actually, I think maybe the most consistent way of doing this is saying that if the pre-address and the post-address are both inside the linked region of the cursor, then I put a hyphen there to indicate they're linked. Let's see if that works. That's just the UI portion. It won't give me the actual updates, but let's see if I can control my wide cursor now. Cool. So now I can kind of grow my cursor and move it around. If I want to have repeating stuff. Oh, I should change. So right now, if I try to grow the repeating region larger than the cursor, it just stops, whereas I think I should have it grow the cursor too. I think that would be a little easier to use. let's do it that way then. Cursor data width. Gotta make sure I don't define a cursor that's larger than the buffer here. Okay, so the cursor itself needs to be larger than the data width, but smaller than the entire buffer. And then the data width just needs to be large, at least one, but also smaller than the entire buffer. And then this has dependency that way now. I think that's what I wanted. Yay, I have those linked bytes. Now let's make them increment as a number. Do I care about endianness? I think I'm just going to support little endian because the processor here is little endian, the file system is little endian. My emulator is big endian, but I don't think anybody cares. I mean, the emulator also isn't going to handle unaligned writes natively, so I'm not going to use this using its own native wide types. Okay, so I have a wide cursor now. And then I have this shared stuff here in interact that handles incrementing and decrementing. Yeah. So let's probably not do this with memset anymore. Yeah, so I think maybe this needs two parts. The first part increments the linked portion of the cursor, and then the second part replicates that across the entire cursor. This will just oh man, gray on gray. It's supposed to say arbitrary width little endian add. So I've got this delta that I'm starting out with from the loop up here, which I'm going to apply to the first byte, and then I'm going to use, basically I'm going to feed that into the beginning of a carry chain. And then I want something roughly like that. Hey, cat. Do you want to play, little cat? You brought a toy. Man, Tuco was super restless the last few days, always asking to go outside, and I think it's because he was having trouble finding bolts. So I got out the air compressor and blew a bunch of them out from the kitchen appliances and stuff, and I think he's been much happier about it now. Oh man, gotta love for loops in C. Hey, Tuco. Hey, Tuco. Hey, Tuco. Okay, I think between the streaming and the cat, my level of concentration is such that I don't know if this is actually right, but let's try it out. Cool. So can I do that now? Yeah, I think that's what I wanted. Let's see if that handles odd numbers. Yeah. Great. I think that is the debugging tool I wanted to give myself for these next few experiments. So yeah, I think I might just use this and set up some kind of long, boring experiments where I see if it's looking for particular file names or for a particular file size. So here I've still got let me just get a control by changing the oh, that's interesting. Why can't I bring that down at all? Oh, I guess I just have to bring the size. That's fine. The UI here is now such that I have to reduce the size of that linked region before I can reduce the size of the whole cursor, but that's fine. So if I go over here to B again and set that to 8, I should see this drop down to a much shorter pattern. Yeah. Okay, so now this is the pattern where it's looking at the files but not very closely. Now we're updating the whole file name, or the whole file size, rather. So yeah, so I mean, one test I can do is basically run through like this with an automated, so turn on the automated advance, and then every couple of seconds it'll update the file size by 1 byte and see if that shows any difference in the execution path. So if it's the case that it's checking the file size before checking the name or instead of checking the name, and it's checking it with a single 32-bit comparison, then this is kind of slow and annoying, but it's the only way we're going to actually get past that check. So that's one thing we could do. Another thing that we could do based on especially some suggestions from chat that like maybe it's comparing this 16 bits at a time, which is a little weird, but you know, could be happening. So if I were to do that and then link the first 2 bytes, maybe fill that with zeros. So now I'm updating the file name in 16-bit chunks. And I would run this and see if any of these show different results. Which is, I mean, this is also kind of weird because this is, nothing in here is aligned. Like it's, I mean, the 8, maybe they're checking the 8, part of the 8.3 file name with wider instructions, but then the extension is its own separate thing usually. Yeah, Pakakizu in chat says, if 2 files are tested, if one is present, then each individual match should change the execution time. Yeah, basically what I mean, if you think about the code that this is running, it's going to be making a series of comparisons for each file inside of a big loop. And so what we're seeing is kind of cumulatively, it's running through this set of instructions and then starting over and running through the same instructions again. And if we can get it past one of those instructions to the next check, then we should see a big timing difference in terms of how long it takes to get to the next individual check, which we can see in the timing or in the power side channel here, or even in terms of how long it takes to issue the next block read at the SD layer, which we would see all over the place, including, you know, at these, both in the power trace and in the digital traces here. So the fact that I'm not seeing a lot of differences so far would mean that it's doing some of the checks in ways that are more kind of all or nothing, like, you know, it's checking more than a byte at a time, or it's calculating something based on several bytes and then checking that. So that's the kind of thing we're trying to look for. And yeah, so like at this point, I'm low on ideas for specific things that it might be looking for that would be easy to check. And so I think maybe the thing to do next is to let this run some kind of slower tests while I work on other stuff. So far, I guess the main ideas for that are, you know, this, you know, wider change to the name, or running through file sizes. I mean, I could also try exhaustive tests on, like, file dates, or, because, like, I don't know what else would change. I can't imagine they would be looking for a specific file timestamp unless they're doing something really weird. And maybe they're looking for something in combination with a file attribute like system or directory or something, but so far we haven't seen anything responding to those attributes other than the volume label attribute. So, all right, well, I think this is about all I've got as far as ideas for the current stream. This is a little bit of a short stream for me, but usually I have a bunch of stuff lined up, and this time I'm closer to the end of what I have lined up at the moment. Yeah, there's a conversation in chat about the file name search. I mean, I would expect it to be looking one character at a time, just because that's, like, if you're writing this code in a common language on a common processor, you have to go pretty far out of your way not to do it that way. I mean, usually you would just be doing like a mem compare or string compare, which would be checking it usually byte at a time, unless it's a fancy implementation of mem compare, in which case it might be checking it using a wider comparison. Yeah, I mean, I guess we could be seeing a really aggressively optimized version of mem compare. Kind of taking, because I mean, these buffers might be aligned. You know, it's the beginning of something that's usually going to be at a 32-bit or a 32-byte boundary in a 512-byte structure. So if we're dealing with something that is at runtime checking to see if the structures are aligned and then copying it using wider loads and stores, or evaluating it using wider compares, then we might be in a situation like this. How long would these exhaustive tests take? Remind me how many seconds are in like a day in various powers of 2. So each of these tests takes 2 seconds. Let's say we wanted to do an exhaustive test of all the powers of 2. Bring it back to minutes and then hours. That's a long time. We need a lot less space to check. If we're only exhaustively testing a 16-bit space, we could do that in like a couple days. So that's basically where we are. I mean, we could certainly design the exhaustive test part of this to run faster. I don't know if that's super productive, though. Yeah, I guess one question in terms of what they might have been doing to implement this is, are they testing the file name first or the size first? If we're looking at a memcopy or memcompare implementation that is trying to like, I can imagine it checking the file name portion of it, whether this is something that was hand-coded to be optimized or something that was optimized by the compiler. I can imagine it ending up with code that would check the first 8 bytes using 2 separate 32-bit compares, but then it's an 11-byte data structure, so you're not going to check the entire thing with 32-bit compares. That still doesn't help us a ton. Any 32-bit compares in here mean it's no longer really possible to just try all of them using a setup that's this slow. That's a good question from Phil. Are there any dictionaries for common file names, like for common passwords? Yeah, I mean, we could get into that kind of thing. Like, I think that would just require more automation. Like right now, this is all designed as something where I can like automate the generation of these test cases, but I'm still looking at the results manually. So I think to go a step further and have something where we are automatically evaluating the results, I would need to write some code that talks to the oscope and downloads the traces and lets us compare them. That also might be worth doing. Oh yeah, Kyle mentions, well, if I assume alphanumerics instead of all the symbols, then it's a lot less than all possible 32-bit values. Well, that's true. If I'm comparing the file name, then it's probably going to be uppercase alphanumerics and maybe a couple of symbols. If I'm comparing the sizes, then I can just start at 0 and increment. And either way, it's a lot less than the exhaustive tests. Yeah. I can at least check in this code that I have. That's partly what I like about working on tools, is that even if you don't find the actual solution to your problem, you can improve the tool. All right, we wrote some code. Oh, and Xkeeper in chat points out that all file names wouldn't work if it was also looking for a directory, maybe? Well, they're kind of related. If we were doing, I mean, if I was really going all out on the exhaustive search, I would probably also want to include the status bit that specifies whether it's a directory or a file. So far, it looks like it's not looking at that until after it's checking the file name. So we would at least be able to see a difference in the power trace and the timing if we hit the right file name, even if we have it marked as a file when it should be a directory or vice versa. So I think some of this is going to, like some of this test setup just depends a lot on the particulars of how they've ordered the comparisons on their end. I think Tuco wants to play Bolt, and I'm a little low on ideas, so maybe we'll do that some. Tuco, you know what Bolt means. You hear him chirping on the stream? He makes such happy noises when he wants to play with that thing. Oh, US Water Rockets in chat asks, could it be looking for a specific disk volume label? I doubt it. Because if it was, I would expect it to like give up after reading. Like there are two places it could be looking for the volume. It could be looking for like a volume file in the root directory, or it could be looking at the volume name in the fat header. Either way, I would kind of expect it to give up entirely after seeing the wrong one, since a normal disk shouldn't have multiple volume labels. Hey Duke, where's your bolt? You're super cute, but I don't see it. Where is it, boy? Hey Tuco, I don't see it, buddy. Oh, there it is. It's way over there. Hey Tuke, I'm gonna need to get up to fetch that for you. You put it way over there. Why? Oh, that's interesting. Mikhail in chat says, I think there was a hit. The delay between the SD traffic went off the screen for a sample in the scope. That's interesting. Let me put the scope back on. I mean, it could have been... Yeah, do you mean while I was changing the contents? Because right now it's static. If you have a timestamp in mind, I can go back and look at it later, or I'll, you know, I mean, I'll go troll through my archive here to see if I hit anything. Well, what experiment do we actually want to do here? File names, file size, I don't know. File names, 16 bits at a time. Playing with the cat. Hey Duke, where's your bolt? I mean, there's also the option of putting this aside and going back to the voltage glitching experiment on the other PLC. You dropped it way over there, Kat. I mean, there also might be the occasional anomaly in the scope, like we're triggering on something unexpected, or there's an interrupt, or there's some other bug in my clock generator. But it does seem pretty stable at the moment. Like you can see on the trace, the CRC values are changing, but the whole code execution path after that is staying stable. Oh, and D11, does that actually matter? Because you can see that wiggling around a bit. I think that might just be that serial line going high impedance and the amount of time it takes to actually drift back up to high state afterwards changes a little bit. So I don't think that's actually anything really outside of our control. Oh, ha ha ha. Pakakizo on the stream says that if this breaks too, then the search could run at double speed. Oh, I really hope I don't break the other one too. I feel like I'd be letting someone down, someone who pays my paychecks. But, you know, that happens sometimes. Alright, well, I think this is probably a good time to wrap up the stream. I'll get some kind of boring experiments going and then kind of shift gears and work on something else, which I may or may not be streaming depending on what that actually turns out to be. Well, thanks for tuning in, everyone, and thanks, as always, for the interesting help and suggestions, and it's always good to have another pair of eyes on these problems. Here's another dose of cat for you all. He certainly seems to be in a good mood with his access to plentiful bolts. I'm certainly looking forward to having the flying Tuco camera that we can all control. Oh, that's also an interesting suggestion from US Water Rockets. Could I SD emulate on the fresh unit to see what it's doing? Yeah, maybe. I would still have to take it apart because I can't actually get this rig into the SD slot with the unit assembled because of the way the case is designed, but I certainly wouldn't have to take it apart very much. So that's the thing. Yeah, I mean, I feel like I was so close to having this experiment running that, well, I had it running and it just bricked very early on. So I feel like if I just reset that up, then I'd probably get myself at least a 64K firmware dump without too much additional fussing. So it might be worth trying that. I guess the downsides there are the risk of breaking that and the annoyance of having to move parts of my test setup over to that one. But the test setup, you know, I don't have to move all the stuff that I tried for testing but now don't necessarily need, so it might just be as simple as clock, reset, some power filtering, and the power low noise amplifier, which is still a decent amount of stuff, but you know, it's probably just a few hours worth of fussing and soldering. So thanks for joining, and happy hacking, everyone.